Good afternoon. My name is Ben Roll. I am an application engineer here with Ally PLM Solutions. Today's Lunch Bytes topic is going to be on the inspect tools in Solid Edge. For those of you who aren't familiar with our Lunch Bytes series, they are designed to explore the features and capabilities of Solid Edge that are often overlooked. We hold them once a month. So if you guys have any suggestions or topics that you would like covered, feel free to let us know. Just send them to us in an email. If you have any questions, same thing. If you have any questions about today's topics, same thing. Just write them down, send them to us in an email, and we'll get you answers to them. We also have a Lunchbyte series for NX for any of you guys who are interested in that. Like I said, today we're going to cover the assembly inspect tools and the part inspect tools. So now we'll jump back over to Solid Edge. So here we're in the assembly environment, and what we're going to look at first are kind of the measure inspect tools that are available. So the first one we have is Smart Measure. It's a 2D measurement tool. So what that allows me to do is come in here and select an edge and another edge. And you notice it kind of works like Smart Dimension. I clicked on one edge and it gave me just the length of that. And then I clicked on another one and it knows, okay, you want to go the distance in between. And you can see it kind of pulls it out just like Smart Dimension does. The difference, once I click, it goes away. That way I can measure another edge or whatever I need to measure. If I want to measure a radius, it'll do that. So that's kind of just, you can click on something and get the measurement without having to place PMI information. The next tool we have is Inquire Element. So you'll notice I can inquire all types of elements, or I can do key points, curves, edges, surfaces. So you can kind of filter through that way if you're having trouble selecting what you actually want to select. So I can come down here and I can select an edge, which is just a line. So it'll tell me I'm looking at a line. Here's the length. Here are the points for each of the endpoints. Or I can come in here to the edge of a circle, click on that. Sorry, it moved me back to Smart Measure. From Inquire, I can click on a hole. It'll tell me, you're looking at a circle. Here's the radius, here's the diameter, the circumference, the center point, all the information you would need about that circle. Same thing, if I come in to a radius, it'll tell me it's a circle arc, give me the arc length and the sweep angle. We also have distance. So you can pick the type of key points you want to go between. You can filter through your elements. So for this, I'm going to start off. I'm going to pick a point there. And you can see I can go anywhere in the 3D space. So I'll come down to this line. It's going to pop up with my window here. I'll go ahead and expand that to make it a little bit easier to see. So it gives me the start point for this coordinate system that I picked, the end point for the point that I picked, and then it gives me the true distance of this line that I just created, gives me the change in X, Y, and Z, and it also gives me the distance and the changes along each axis relative to the perspective that I'm viewing it right now. So the way I'm looking at it right now, that line appears to be a different length than it actually is, and that'll be a little bit clearer when we look at the angle. So just from that, I can come off here and I can start picking other points. So it'll measure this whole path as a cumulative measurement. It'll tell me the total, everything, and then it'll also break it down into measurement 2, measurement 1, so you can see the little 1 right there, If I rotate this around, you can see the little 2 a little bit better. So that tells you what each of those measurements are. We also have a minimum distance, which is a little bit smarter than the just plain distance tool. So if I click on these 2 edges, it'll bring it up. It'll tell me the distance from there to there is going to be along the Y. So it'll give me that distance, and then it'll also tell me the change and the endpoints of the 2 points. We also have normal distance. So what that would be used for, go ahead and make sure all my points are, or all my parts are active. So the normal distance, I can pick this face. I want to come normal off of that, and I want to come to the end point here on this part. So if I just pick that end point, it'll give me the normal distance instead of just a line along there giving me the change in each direction. So it says normal to that face is the y-axis, so it gives me that distance. Now we have the angle 3D measure. So just like with all those other ones, you can kind of filter it out. So by default, it would be most likely on lines and planes. So it'll pick up a line, there it'll pick up a line, there it'll pick up a face. So that can be a little hard. And especially like for the angle, I just want to do a plane. So I just want to go between this plane and this plane right here. So now what it'll tell me is it'll tell me the true angle between those. So it's 90 degrees. It'll give me it in radians. And the apparent angle. So the way my view is right now, it looks like that could be almost a 45-degree angle. So to kind of show you how that changes, so the way my view is now, it looks like that angle is one thing. But if I kind of rotate up and come more over top of it, now it looks more like a 90-degree angle. So when I go and measure that, it tells me, yeah, now from my view it looks like it's about 88 degrees, so almost 90. The next tool we're going to look at are the physical properties. So this, just to kind of show you here, we'll look at it in more detail later. It's the physical properties for the entire assembly. So for this, I don't have materials assigned to these parts to give it a mass. So it's just going to show up as everything 0, like there's not really any physical parts there. So one way that you can fix that if you're in an assembly is the physical properties manager, which is our next tool. So what that's going to allow you to do is instead of coming into each part individually and selecting and changing the physical properties for that part, it'll pull up all the sub-assemblies and all the parts that are in this top level assembly. You can see some of them are up to date, they have material. Some of them don't have material. Some of them are not up to date. So I could come in here and I could pick a material for some of these, and that would then give it a density. Or if I come up to update all, what that'll do is pull up a new window telling me, hey, you have parts in here that don't have a density. So you can then pick a material as your default material. So you'll see here where it lists default material, default accuracy. It'll put those into all of those sub-assemblies and those parts, and you can tell it to go ahead and save that to the document if you want. So that's how the property manager works. Next, we're going to look at the interference. So we're going to check for interference. So with that tool, we're going to go ahead, and this just kind of shows you how it works. We're going to pick our first set, accept that, Now we'll pick our second set. So we'll just pick these other parts in here. And we'll accept that. And now we'll look at the options. So there's a few ways that you can set up these interference checking options. So it's going to check set 1 against a certain set. So our set 1 is that first set that we picked, so it's these blue bars right here. So right now it's set to check set 1 against set 2. So it'll check if these blue bars interfere with the green parts. Or we can set it to check for all other parts in the assembly. So it'll check just these blue bars against all the other parts in the assembly. But this is kind of a large assembly, so maybe you don't want to do that. Maybe you're only interested in what you have showing. That's where you could pick the next option, which is check set 1 against the parts that are currently shown. Or you can check it against itself. So that would say, do any of these blue parts interfere with each other? You also have your output options, so you can generate a report which will tell you the information about that interference check. You can set for the volume if you wanted to just show the volume or save that volume out as a part. So if you save that out as a part, it'll save that volume so that you could then use that to Boolean out the area so that you no longer have interference. You can also hide parts that are not in either select set. So that kind of makes it a little bit easier to tell what's going on once you process it. You can highlight the interfering parts, you can dim the parts that do not interfere, and you can hide the parts that don't interfere. For holes and threads, we have some options where we can ignore the interference between the matching threads. That way, because you're not going to be worried about that if you know you have the right threads selected, they're going to interfere, so you can just ignore those. The same thing with threaded fasteners. So if you have a threaded fastener in a non-threaded hole, it'll ignore that too. So now for that report. If we come into our report options, it'll tell us where it's going to save that report, and we can also pick what we want included in that report. So part name, part center of gravity, interference center of gravity, interference volumes. So we're going to hit OK, and we're going to go ahead and process that. And you'll notice there aren't any interferences within this assembly that we're looking at right now. So it tells us what you selected does not interfere. So we say OK, that's good. But maybe we want to look at something that does interfere. So if I come to this view configuration, which some of you guys might be familiar with, this is from the Dixie Chopper lawnmower. So for this, what we're going to look at is, again, the interference. And we can kind of see that there's some interference with this part. So our first set is going to be this beam right here. Our second set is going to be this pulley, this belt, and this bar down here at the bottom. So we're going to accept that. We'll go back into our options. Okay, we want to dim the parts that don't interfere. And we have our report already set up. So now we'll go ahead and process that. And you'll notice it changed the color of this because it dimmed it out, so it's just the outline of it showing, because that does not interfere with our beam. And it's telling us that, hey, these parts do interfere, and here's where they interfere. So now if we go to that report, and I open that up, it'll tell me, you know, when I ran it, what options I picked, what the select sets were, and now the interferences. So it's saying it found 2 interferences. So we have the first one, and it'll list the parts, where those parts are located, and the volume, and where that's located. So you can see here's the volume of where it interferes. So that, if I can get it to show, is going to be the interferences here. And now the second interference, you'll notice I have 2 volumes, and they're both the same. So that is this little section here where that belt interferes. So that's how you can check for interference inside of your assembly. Next, we'll look at the assembly statistics. So that's going to pull up all the information about the top level assembly. So it'll list how many parts we have. We have over 1,000 parts, 325 of them are unique, how many are simplified, and the total levels in the assembly. It'll give you the same information for sub-assemblies, how many there are, unique, simplified, give you the size, and down here it'll give you all the documents that are inside of this assembly, and it'll give you what type they are, if they're active, inactive, file size, and how many times they're in there. So you'll notice here's a part that's in here 29 times. So it gives you that sort of information that you might be interested in. So now we're still going to look at some assembly features, but just to make it a little bit easier so we don't have so much other geometry in the background, we'll go ahead and switch to a different assembly. So this is just the wheel, still from the lawnmower, and we're going to look at the geometry inspector. So for this, you can pick top level or just select certain occurrences. So I'm just going to go with the top level, and it'll look for faults or small entities. So for the small entities, here we have faces, slivers, spikes. You can pick area if you want, and you can also look for edges. So we're going to go ahead and pick those with our tolerances for that. We'll go ahead and run the inspector. It'll give us our results for that assembly. It'll tell you where it found stuff, so which parts. So we'll just open up this first one, and it found 10 small entities, 10 faces, 5 small faces and 5 sliver faces. So if we just come into the small ones, it'll fit and show us where that is. So for this, if we come here, rotate around, that's not a problem. You know, it's a small face, it's a small part. So what you would generally use this for is if you're importing geometry to kind of make sure you don't have any small faces that you don't want, and to find those so that you can fix them if need be. So that's how the geometry inspector works. Next, we have recognize holes, which I'll go ahead and show you. So for that, we're going to have to open up an IGES file, which is what that's the inspect holes or recognize holes is for. It's for if you bring in geometry from another CAD system and you no longer have the history of it. So you don't have your Pathfinder, it just comes in as a part copy. So here, what we have is an engine from an ATV that something I was using for school. We had to model it for our race car. So what I'm going to do is run recognize holes, and you'll see it'll pick up all the holes that are in this part. So if I hover over them, it'll highlight them, tell me where they are, what it's going to name them. I can select if I want it to be a different type of hole. I can pick that. It'll tell me what type it is and what the diameter is. I can also, maybe I don't want this first one to be recognized as a hole. I can turn that off, say OK, and now it brings all those in as holes. So I can come in here, and let's pick this one. It's in there as a hole now, and I can come in here and edit it just like I would a hole. Say maybe I want that to be 10 millimeters, and it'll change it, just like you would a normal hole if you had modeled this inside a Solid Edge. So we'll go ahead and close out of that one. We also have goal seek and relationship colors, but those are also available inside of the part environment. So I'll just go ahead and show you those inside of the part instead of inside of the assembly. So the first part we're going to look at is this part 2. And what we're going to do, you'll notice here in the middle, that is the physical properties. So if I go into that, I have my center of mass displayed, my center of volume displayed. Notice it calculates all my mass moments of inertia. If I go to the principal, it It'll give me the principal moments of inertia and the radii of gyration, and I have the principal axis shown there. What I can do in here is, if I say I want to change the material, this is kind of an important thing if you're in here and you want to change the material. Let's go from aluminum to lead. So we'll go ahead and we'll apply that. And now we'll look at the physical properties again. You'll notice it says it's 15 kilograms, but all this information here is still tied back to the aluminum. So once I update it, now it changes, and now you can see it's actually 65 kilograms if it was made out of lead. So you have to be sure to update that once you change your material in order to get your physical properties updated. So now what we'll look at here, first we'll look at some of these analyze tools. So the first one we'll look at is the draft faces. So you'll notice I have draft on here. We'll go ahead and show the draft faces. So it's separated out into two colors. The draft is split along here in the center where you might have a parting line for your part. So if I go into the settings for the draft, I can pick the colors that I want. You'll see red right now is a negative draft face, yellow is a positive, and I can change that if I want. So up here it's asking me to select a plane, so I can pick that top plane, pick a direction, and now because of that direction that I picked with that plane, this counts as a positive and the bottom is now negative. So that's how the draft face works. Now we'll go ahead and look at this curvature cone. So for that, what I need to do is come in here, and on this top face we'll go ahead and lock to the plane, and I'm just going to draw what's supposed to look somewhat like just a simple sine curve. And we'll go ahead, come back, you see I have it turned on. So now if I come back into my sketch, what I have to do to get that to show up is turn on the curvature cone, and you'll notice it kind of makes these polygons for me to check how smooth that curve actually is. It's kind of just a graphical representation for you to check your curve and see how the curvature behaves. So you notice here the curve increases a lot, the slope is a lot larger, down here it's a lot smaller, and you can kind of tell along the line how that changes, and it's a lot more exaggerated along the cone than it is on the line itself. So that's how that works. Next, we're going to go ahead and hide that sketch, and we'll just come into the bottom face for goal seek area, and there's the relationship colors. So what we need to do is just on this face, we'll go ahead, we'll lock to it, we'll just create a simple rectangle. We'll go ahead and put some dimensions on that. So for this we'll say 50 by 50. So kind of create that. And now we'll go back to our inspect tools. And you'll see now I can select area. Before it was grayed out. So I want to go ahead and pick the area. And what I'm going to do is just select this inside area. And you can see by my cursor it tells me it's 2,500 square millimeters. So I'll go ahead and accept that. And you'll see it makes it into an area. If I hover over it, my quick pick, it shows up as an area object. And now I want to do goal seek. So the way goal seek works, I have a goal that I want, and I can pick it from this drop down. One thing you'll notice, because I did the area, I now have a perimeter. So when it calculated the area of that square, it also calculated the perimeter. So I can pick just the area of that. I also have this hand, which lets me graphically select what I want. So I could have picked that and then picked that area object. Now I can input a target. So maybe I want 3,000 millimeters squared, and I can pick a variable. So here it lists my variables that I have, or I can come in here and just pick one, and it'll pick that. That way, if you don't have them named right, you can just pick the one you want. So I'm going to go ahead and accept that. And you'll notice that it's changing that variable, and it's running through different combinations of it to get me this target area that I specified I wanted. So it'll run through that, and it'll come back with, you know, whatever change it picks to give me that 30,000, or sorry, not 30,000, 3,000 millimeter area. So now it changes the current to what I wanted. We also have this relationship colors. So what that does, if I come in here, you notice my sketch is blue, and what I'm going to do is I'm just going to fully define that sketch. And for those of you that have been using Solid Edge for a while, you remember back in earlier versions in the ordered environment, you could set it up to automatically, once you fully constrain a sketch, to change the color. So where that color comes from is in Solid Edge Options under Colors, and we have Sketch Relationship Colors. So user defined is what I just have. Here's the blue. Fully defined is black. So if I come back to this, come back to my Inspect Tools, and turn on Relationship Colors, now it'll change that to black. So if I have that turned on and then fully define my sketch, it'll automatically change from blue to black to let me know that, hey, you fully defined this, you don't need to put any more dimensions on it. So now we still have zebra stripes and curvature shading. So to show those, we're going to come back to this engine. Actually, real quick, just to give you a better idea without killing your eyes, I'll turn on zebra stripes. So in the settings, I could change the colors if I want. I can change the stripe thickness, number of stripes, the quality, the mapping. So what the zebra stripes is used for is to kind of look at the continuity of the curves, so how continuous those are. You'll notice that all these stripes are nice, smooth lines. As you rotate, it does move. It's a little funky looking, can kind of mess with your eyes, but it is a useful tool. So you'll notice the curvature of all these faces is nice and even. It's all continuous. But if I come to this engine, which was modeled by students, so it's not the best to begin with, if I look over here on this side and I turn on zebra stripes, it's not too bad. Those are fairly straight, normal faces. But if I come up here and look at this bottom face of the engine, you can see how now they're a lot more jagged and kind of just end at places. So that kind of tells you that the surfaces along there are not continuous. So you can use that to check those sort of things. We also have curvature shading, which, just to give you a little example of how to use that, what we wanted to do was, this is an old model engine, so we needed to add some material to it to make it look more like the engine we're using now. So just an example of what we did, we kind of added a region here and used that to add material. Well, right now we have it treated as a closed region, so it's going to follow this bottom line here across the surface. Well, if I try and just extend that across, it won't let me. It gives me an error message. If I come up to treat it as an open profile, it'll let me, because it just takes these two lines and goes all the way to the next surface that it intersects and just booleans on top of that. Well, in order to figure out why that is, if we turn on curvature shading, I'll zoom out here so you can kind of get a few more faces to look at. It'll tell you how the curvature is along that face. So here where it's red, the curvature is the same all the way across that face. Same with black, just kind of breaks it up. Here by my cursor, you'll see a little stripe of orange, but that's still pretty uniform all the way across. Down here, you see some green. Along the middle, it's kind of uniform, but you've got some curvature up here and some curvature down here. And now let's look at the problem area we had. Well, from here, it's pretty much nice and uniform through this first section here, but then this section, you can see it kind of drops off, and that's what the problem is. If we just followed straight along this line as a closed profile, then we would have a gap here because that face, the curvature along that face, is not the same. So it changes, which is what gives us that error message. So that's how you can use this curvature shading to kind of help you with your model if you run into an error. That way you can see what your faces are doing and what might be causing that problem. So that is all we have for this topic. I want to thank you guys for your time. Here is our contact information if you have any questions about what you saw today, or if you have any suggestions for future Lunchbyte sessions that you would like to see. Feel free to contact us and let us know. We have replays of all our Lunchbytes up on our website, so you can go to our website, allyplm.com, or if you have a smartphone, you can scan this picture here, a little barcode, and that'll take you to our website where you can get to both our NX Lunchbyte replays and our Solid Edge Lunchbyte replays. Once again, if you have any questions, feel free to contact us. Thank you for your time. Have a good afternoon.